Hi, welcome back. Algebra 1, um, lesson 3b.3, which means we're on module 6, I think it is, in the online book, which is also called Unit 3b, which is graphing quadratic equations. And so what we're going to do in today's lesson is begin to look at the vertex form. I hinted at this a little bit um, in our last lesson where we got to see the different, there we go, got the lesson up, where we got to see how to graph using standard form. And I mentioned that we would get into vertex form in the next lesson. So that's today. So that's what we're going to do. There's a lot to go over, so stick with us. The first thing we need to talk about is what is the vertex form? Well, the name of it should give us a hint. It should easily identify for us what the vertex is. So what we have here is f of x. This is in its function form. If it was in its equation form, it would be a y. If we were solving for this, it'd be a 0. So there's 3 different ways to write just this one part of the equation, right? But the vertex form is a times x minus h squared plus k. Now this h and the k might seem a little familiar to you because remember your exponential equations also had h's and k's. So that's what we're going to look at, just like when our exponential equations had h's and k's and how that transformed our graph by shifting it horizontally or vertically, or we had some stretching or compressing in those exponential graphs. We're going to have the same thing here in our quadratic equation. So specifically in the vertex form, what we see is that A will either reflect, stretch, or compress the parabola. So if A is greater than 1, so like 2, 5, 7, it's going to stretch it. Remember, that's as if somebody were, when we had the exponential form, we would see it as if somebody took the top of it and just started pulling it up. Well, when you have a parabola, it's if you took both pieces and started pulling it up. So, and essentially your parabola that's like this U shape will get skinnier when it's stretched because it's being pulled up. Alternatively, if it's compressed, if A is a fraction or a decimal, so less than 1 but greater than -1, it's going to be as if somebody's pushing down on it, right? And so what would happen to this U shape if somebody were to push down on it? It would crunch up, right? It would get fatter and fatter and fatter. So we'd go from a parabola that looks like this, if somebody were pushing down or compressing it, to getting wider and wider and wider, okay? So original parabola, stretched, original parabola, compressed. All right. So, but there's a third option that can happen with A, just like when we had our exponential growth graph. It could be reflected over the x-axis. We took it, and if it were going upwards and we reflected it, it would now be going downwards, right? Same thing with our parabolic graph. Let me actually draw it. So if we have a quadratic parabola, it would normally look like this. It opens upwards. But if A is negative, it's going to look like this and open downwards. So that's all the negative or positive of the letter A will do for us. And then depending on whether it's a number greater than 1, a value greater than 1, or a decimal, it will either stretch or compress it. Now, H stands for horizontal. H stands for horizontal. So that means it's going to horizontally shift it right to the right or to the left. And just like when we transformed our exponential graph, you notice that this right here is a negative sign. So when you're looking at the written form of the equation, it's going to be the opposite of whatever you see here is what H is. Okay, so if it's a +2, then H is a -2. Because this right here means opposite, right? Because if we plugged in a positive number, this would look like a negative. And if we plugged in a negative number, this would become a positive. Okay, now a positive H will move the graph to the right, and a negative h will move the graph to the left. Okay, so that's h, horizontal. K is our vertical change. Remember, h is an inside change, meaning it happens directly to x before it is squared. Okay, an inside change. Now, K is what we call an outside change because it's happening after the square. Okay, it's outside of these parentheses. And K is the vertical change. So it's going to move it up or down. And it's just a normal so whatever is put in for K is what it is because there's a plus here. So if K is a positive 2, the graph, which would normally be here, moves up 2. Everything just moves up. If it's a negative 3, whatever graph is here would move down 3. And everything else would stay the same if all you're changing is the K. Okay? Now, more to the point of why this is called the vertex form is because H and K are what make up our vertex. H is the X in our vertex and K is the Y in our vertex. So essentially HK is the vertex of the parabola. So we can look at this form and easily see what the vertex would be. It makes it really easy for graphing and very, very, very helpful when you have it in that form. So what happens though if you have a standard form of a quadratic equation and you need to put it in vertex form? How do you do that? Well, there's two ways to do that. One, you're already familiar with, completing the square. We know how to do this, right? What do we do to complete the square? We start by writing the first two terms exactly how we have them, right? Remember, we've only learned this where there's no, where a is 1 in our standard form. So there's no leading coefficient here. So x squared minus 6x, we write that. And then we're going to put equals. We're going to move this minus 9 over to the other side and do plus 9, okay? And then, do you remember how we got this number that we're going to input right here? We had to take half of this center number. Half of negative 6 is negative 3. And then we had to square it. Well, when we squared negative 3, that became a positive 9, right? So we're going to add 9. But if we do it to one side, we have to do it to both sides, okay? So then you're going to have x squared minus 6x. Oops, let's go ahead and erase this. When we complete the square, we can just go ahead and do it this way. We know that it's going to be, because of our minus sign there, we're going to have a minus here. And we have an x, and the square root of 9 is 3. And then 9 plus 9 equals 18. This is how we would complete the square. But to get it into vertex form, we need to have it equaling 0. So how do we do that? We're going to move the 18 back to the other side. And there you go. Now we have it in vertex form. You can see that a is 0, h is 3, positive 3, right? Because we're always taking the opposite of what we see. And k is, let's write it out. A is 0. There's no b in this. B is negative 6, but we're looking at vertex form. So there's an h. H is positive 3, and k is negative 18. All right, so in this way, we're going to find the vertex. Remember how we found the vertex before? We said the x of the vertex is found by taking negative b divided by 2a. Okay, well, let's look up here. Remember, a is 1 and b is negative 6. So we're going to do the opposite of b, and if b is negative 6, the opposite of b is positive 6, over 2 times, what is a? A is 1. So 6 over 2 is 3. So, excuse me, if the x of our vertex is 3, that means 3 is our h. And how did we find out what the y of our vertex is? Well, we just plugged this 3 right back into the equation and solved for y. So y equals 3 squared minus 6 times 3 minus 9. I've got a calculator here. So I'm going to do 3 squared minus 6 times 3 minus 9. Hit enter. And you know what I get? Negative 18. Okay, so now we're just going to rewrite this equation. as 0 equals, and the sum of the y equals. We could write the y equals. That's probably better if we had y instead of 0. Let's do that, because that's what we have up here. 0 is for when you're ready to solve it. We're just writing it in vertex form. So y equals, and then our a is 1. The a is not going to change. So we still have an a of 1. And vertex form, remember, is a times x minus h squared plus k. We can say y equals. Okay, so a stayed the same. It's still 1. So I don't need to write that. It's understood. So I'm going to start with parentheses x minus, what did I say my h was? 3. And then plus k. What did I say my k was? Negative 18. Did I get the same problem? X minus 3 squared. Oops, I forgot to write my squared. I apologize. X minus 3 squared minus 18. There we go. And we got the same formula, the same equation rather, for both of these. So you can move from standard to vertex doing it the exact same way. And to move from vertex to standard, all you have to do is expand this by squaring this, foiling it, or however you do, x minus 3 times x minus 3, and then combining all your like terms. All right. So here we have 3 different equations, and I want us to determine, oops, did not mean to move forward there. Apologize. I want us to identify what the vertex is in each of these transformations that's happening to each of them. So let's start with the vertex, because that is usually the easiest. So remember, our vertex is going to be h comma k. All right, so let's look at this. What is our h in this equation? Well, h is the opposite of what we see. So I see a positive 3, and it's inside the parentheses. So that means my h is going to be negative 3. Now, k is what's added to the end. There's nothing that's added to the end. So how do I represent nothing? With a 0. So my vertex is negative 3, 0. Now my horizontal shift, remember H stands for horizontal shift. Let's go ahead and write our vertex form up here. We're going to have a times x minus h squared plus k. All right. Horizontal shift stands for h. Remember, it's the opposite of this. So if h equals negative 3, our horizontal shift is going to be to the left 3. Okay, vertical shift, remember, is our k. So in this case, our k was 0. So that means we have no vertical shift. Stretch or compress, that's our a, remember, our a. So our a in this case is 2. So what's happening? Is it stretching or is it compressing? It's stretching by a factor of 2. Is it reflecting? Well, remember, to reflect, that would be if A were negative. If A is negative, if there's a negative in it, then that tells us whether or not it reflects. Since this is positive, our answer is no. We have a positive 2 for A, so it is not reflecting. It's going to open upwards. Okay. All right, let's look at this one. Our vertex, again, being HK. Let's identify H is positive 2, because we're going to take what we see, the opposite of what we see here. And then K is 1. So this is going to be 2, 1. Just as a side note here, what is the axis of symmetry? AOS, axis of symmetry. Our axis of symmetry is going to be x equals negative 3. And here our axis of symmetry is going to be 2, x equals 2. Okay, so keep that in mind. Just because I'm not asking for it doesn't mean you can't identify it. All right, so H, our horizontal shift. Our horizontal shift, it's going to be what? Right or left? Well, it's a positive 2, so it's going to be right. Right 2. All right, K is a positive number, so it's going to be up 1. All right, what is A? A is -1. So already with the negative, I'm going to put a yes here. All right, so -1, it's not going to stretch or compress at all. 1 doesn't change anything. The negative changes the reflection, but the number 1 means that it's not going to stretch or compress at all. Okay. All right, so let's move on to this one. Let's look at H and K. H here is going to be +4. K is going to be -3. So in this case, we're going to have 4, 3 as our vertex. And what is our axis of symmetry? X equals 4. All right, so if H is 4, our horizontal shift would be right 4. We're going to move it to the right 4. And if K is -3, we're going to go down 3. Okay. Is it going to stretch or compress? That's determined by our A. A is 2/3. It was positive, so there's no reflection. A is 2/3. That's a fraction. And it's a fraction that's less than 1, right? You have to be careful. Sometimes they give you fractions that are greater than 1 just to trick you. But if A is 2/3, that's a fraction that's less than 1. So we've got a compression by 2/3. Okay. So that's how you would fill out a chart like this. You're going to want to identify each of the transformations that's happening that you can read from the equation that you are given. All right, so here we've got some of these equations. And this time, we've seen this chart before. We had it in standard form, but this time it's in vertex form. And we still need to identify those key features. Number 1, what is the vertex? Well, this is a lot easier to find than it was in our standard form. So our vertex, let's go ahead and label these. A is 1, H is -2, and K is -1. All right, so vertex, remember, is HK. Okay, so if H is -2 and K is -1, here is our vertex. All right, the graph of this is going to open upwards. We're not going to graph it today. I don't have room for a graph here. Actually, I might do it on Desmos in a minute. We'll see. Axis of symmetry in this case, X equals -2. Y-intercept. Y-intercept. You know, we didn't get into that too much, but when you have standard form, I think hopefully you noticed that when you had standard form, it was just whatever C was. So the y-intercept was really easy to find in standard form. However, in this form, we do have to go through the process that we went through last time where you plug in 0 and see what you get. So we're plugging in 0 for X, and we're going to have 0 plus 2 squared. Let me go ahead and put this in. 0 plus 2 squared minus 1. And we're going to use our calculator. Parentheses, 0 plus 2, close parentheses, squared, minus 1. And what do I get? I get 3. So my y-intercept, I'm going to have 0, 3 as my ordered pair. Remember, they're asking for the intercept, so it should be in an ordered pair. And if they're asking for the y-intercept, you need to find the y, and the 0 is going to be the X is going to be 0. Okay, so the X intercepts the exact value. We've gone over how to solve those, so I want you to be able to do that. We're not going to do it today because we got a lot to get to. F of X here, we have A is -1/2. H is +2 because it's the opposite of what you see there. And K is 3. So our vertex is 2, 3. This is going to open downwards because of the negative we see right there, okay? And if you notice, this one's going to be compressed. Our axis of symmetry is X equals 2, and our Y intercept is going to be -1/2, open parentheses, 0 minus 2 squared, close parentheses, then squared, plus 3 equals, did I do this right? Let's see. No, I did not put it in correctly. I'm going to try this one more time. 1/2, negative 1/2. Negative 1/2 times, or open parentheses, x minus 2, close parentheses, squared, plus 3. Let's see if this is going to work. My calculator's trying to put in extra parentheses for me. So I'm going to have to do it how it wants me to. Parentheses, negative 1 divided by 2, close parentheses, open parentheses, 0 minus 2, close parentheses, squared, plus 3. There we go. It worked that time. 0, 1. All right, so here we have a equals 1, h equals 7, and k equals negative 3. Oops, sorry, positive 3. What's that, positive 3? Because k, we do not find the opposite. We only find the opposite for h. So this is 7, 3 as the vertex. I know that this is going to open upwards. And let's see, axis of symmetry is going to be x equals 7. And let's find the y-intercept, open parentheses 0, minus 7, close parentheses, squared, plus 3. Ooh, 52. Is that right? 0 minus 7 squared plus 3. It is. So 0, 52. I'm glad we are not graphing that. Well, we could have graphed it other ways, but it would have been a very large graph. We'd have to move the page all around. Okay. Let's describe the transformation here of f of x from f squared. So g of x is the transformed version of the parent graph. So the black graph you see here is what we call the parent graph for a quadratic equation. It's simply x squared. Okay, so how has x squared been transformed to give us the blue graph that we see here? Okay, so a couple of things to note. Let's look first at the horizontal transformation, not horizontal, vertical transformation, k. So we know we're going to need a, we know we're going to need h, and we know we're going to need k. All right, so let's look at k. It moved down 1. So if you notice, the vertex is 1 lower than it was on the original graph. So it means our k is negative 1, okay? So now let's look at our horizontal transformation. It was 1, 2, 3, 4 to the left. And the left is a negative, so h is negative 4. Okay, now that brings us to a stretching and a compression. So it gets a little bit more complicated here to see the stretching and the compression. But the easiest way that I think you can identify if something is stretched or compressed is by looking at where it is on the original in relation to the vertex and where you can find points on the transformed graph in relation to the vertex. So when we look at the vertex here and we go over 1, our point is, so if our x is 1, our y is also 1. So we've gone over 1 and up 1. And it's the same on both sides because remember, this is symmetrical. So if we have that on here, then we probably do not have any stretching or compressing. So over 1 and up 1. Oh, good. It's on the graph. Over 1 and up 1. It's on the graph. Okay. Well, let's look at what happens if we go over 2. Where is the graph? Well, it's up 4. So we went over 2 and up 4, over 2 and up 4. So let's see if on the blue graph it did the same thing, just to confirm that there's no stretching or compressing. So if we go over 2, 1, 2, 3, 4, it is definitely on our graph. Over 1, 2, up 1, 2, 3, 4. So A is 1. A is not 0. A is 1. Remember, 1 is going to be what makes it disappear. It's going to perform a magic trick, a disappearing act. So let's write this. We know our form is going to be y equals a times x minus h squared plus k. All right, a is 1. So I don't even need, oh, you know what? It wants me to write it not in y equals. What is it? How does it want me to write it? As g of x. G of x is, a is 1, so we don't need to write that. X minus, what is h? H is a negative 4. If I plug a negative 4 into here, it becomes a positive 4 squared plus k. Oops, k is a negative 1, so I'm going to put a negative 1 here. And this is my vertex form of the quadratic equation for g of x, the blue graph here. So hopefully you can build your equations from looking at how it has transformed from the parent graph of f of x is x squared. And this is the parent graph no matter what for any quadratic equation, whether you're told that or not. Now I want to look at Desmos. So we're going to go here to Desmos, and I have a number of equations here up on the screen for us. I have our parent graph in red graphed for us, y equals x squared. So we have that on here for us to just kind of see what it looks like, so we can just make sure. First thing I want us to see is, what would it look like if we had y equals negative x squared? Okay, well, remember, this is different from y equals negative x squared in parentheses. So all that's happening here is our a is negative. That's the only change that we had. So you're still going to have your vertex at 0, 0, and then your 1 is going to also be at 1, and your 2 is going to be at 4. And it's going to reflect across the axis of symmetry exactly the same. Okay, so let's look and see if I got that right. Turn that graph on. There you go. I got that graph correct. Now, how would it look if instead of having negative x, I had y, if I had, let's see, if I had those parentheses on here around the negative and the x, how would that change it? Look at that. How it changed it is it didn't change it at all, because a negative times a negative, look, the blue and the red are the same graph. Why is that? Well, that's because a negative times a negative, two negatives create a positive. So it's the exact same thing there. Okay. All right. So now let's look at 3x squared. 3x squared. How would that change? Okay. Well, I already know that the only thing that's changing on it is a, right? And since it's a positive whole number that's greater than 1, I know it's being stretched. So it's going to be a skinnier graph, a skinnier parabola. But what does that mean for me? Okay, well, I'm going to square it first and then multiply it by 3. So it's being stretched by a factor of 3. So if I go over 1, instead of being up 1, it's going to be 1 times 3. So my y value is being multiplied. My y value here is 0, 1, right? But my y value for my 3x squared is going to be at 1, 3 right here. 1, 3. And then this is going to reflect over this way, and we're going to have a negative 1, 3. Okay, so where do you think, if x was 2, where would y be? Well, in this case, it's 2, 4. So in our stretched graph, it would be 2 and then 4 times 3. So 4 and 12. We don't see the 12 right here, but that's what you would have. So let's turn on this graph and make sure we got it correct. Oops, that's not the graph we're turning on. This one here. And as you can see, it went through those points that we found on the graph. So what would happen if you were to compress this graph? Instead of, let me keep this graph here and let's draw it in. And I'm going to change this. Instead of being 3, let's change it to 1/3. Remember, this was right here was 1. Oops, that's supposed to be a 1. 1 comma 1. And this was 2 comma 4, right? So if we had y equals 1/3 x, how that would change is our 1 would be, our x would still be 1. X is still going to be the same. And our y would be divided by 3 because it's 1/3. It's being multiplied by 1/3, right? So 1 times 1/3 means it's going to be all the way down here, right? And 2 is normally 2/4, but in this case would be or 2 comma 4. 2 is the x and 4 is the y. In this case, it would be 4/3, or 4 times 1/3. And so 4/3 is 1 and 1/3. So 2 would be 1 and 1/3. All right, so let's copy these over on this side. If we were at 1, it would be, okay, this is 1/2, so 1/3 might be a little bit higher. I'm not sure exactly where 1/3 is. And then -2 would be 1 and 1/3, about right there. So let's change up this graph, this green graph. Instead of saying 3, let's say 1/3. And you can see my 1/3, I wasn't sure exactly where they are, but we got very close. So you can see how a stretch or a compression really just affects the y value in your ordered pair. All right, so we're going to turn that off. And let's look at this one. This has got a few transformations here. We've got y equals 1/5 x squared minus 4. Let's see if we can figure out where this is. So I already know that it's going to go down 4. So my vertex is going to be all the way down here. There's no horizontal shift at all. So it's going to stay on the y-axis, and it's just going to go straight down -4. Now, I also know that my y values are going to divide by 5. So if this 1 is 1, this is 1, 1, remember, and this is 2, 4, then my my first point is going to be 1, what? 1, and then 1/5. And then my second point is 2 and 4/5. Okay, so, but you have to remember we went down. This is 4/5. This isn't actually 1/5 and 4/5. This is 1/5 up from the vertex and 4/5 up from the vertex, right? So these aren't an actual ordered pair here. This is just telling me how much I need to move from the vertex. So I'm going to move over 1 from the vertex and go up 1/5 from the vertex. Okay, so this one I'm going to go over 2 from the vertex and go up 4/5 from the vertex. Okay, so it's going to happen the same over here. And again, I don't really have the fractions on this graph, so I'm not sure exactly how it's going to look, but we'll see how we do. All right, so our problem for 3 would be 3. Well, what's 3 squared? 3 squared is 9, right? So 3 and 9. So if I want to know what my transformed one is, it would be 3 and what? 9/5. 9/5 is the same as 5, is the same as 1 and 4/5. Right? So if I went 3 from the vertex, 1, 2, 3 from the vertex, and I'm going to go up 4/5, 9/5, excuse me, which is 1 and 4/5. So it's going to be right about there. Right about there. All right, let's see how I did. Let's turn this on. Oh, I was pretty close. I'm excited about that because I couldn't see those fractions. There we go. All right, remember, these are not the ordered pairs. This is just how far I traveled from the vertex. To find the ordered pairs, you would figure them out on the actual graph, okay? So that's how you can graph from vertex form all of these equations. Now, usually in your book, you will not have too much of compression and stretching of your graph. You probably won't get fractions in there, but it's good for you to know how to do that. All right, so I want to get back to our slides here. I want to talk about real quick, and this is how we're going to close up today, the three different types of equations, forms of quadratic equations that we've looked at. So the first one we looked at was standard form. A times x squared plus b times x plus c equals 0. Or you could say y, or you could say f of x. Remember, f of x is the function form, y is the equation form, as 0 is when you're trying to solve for it. So it can be set to either of those, or you could just not have this side and just have an expression, just have ax squared plus bx plus c. All right, so this form allows us to easily identify the y-intercept. Remember, the y-intercept is simply 0, c. And that's your y-intercept. So right there, it identifies what the y value of your y-intercept is. And this is also the form that you would use in order to use your quadratic equation to solve to find your solutions, your roots, or your zeros. Remember, all those different words mean the same thing. Which brings us to our second form, the factored form, sometimes called the zero or the root form. So this is after you've factored it out of standard form, you should be easily able to see what the solutions are. So in this case, m would be any common factor that you factored out, the GCF, right? And then you have two little n's here, n1 and n2. And these n's, the opposite of them are always the answers. But you have to be careful. This one's tricky because if you have a coefficient before the x, it's going to be a little bit more complicated than just taking the opposite of each of those. Okay, so you got to watch out for that. But that allows you to easily see the solutions, the roots, the zeros, when you're asked to solve. And then the last one is the vertex form. That's what we were going over today. The vertex form allows us to easily find the axis of symmetry as well as the vertex. Our vertex is going to be HK. So H is the X value of our vertex and K is the Y value of our vertex. This is the easiest form for me to be able to graph because it gives us so much information just from looking at it. And again, with these, instead of the 0, you could have f of x or y in any of those. And the axis of symmetry is just going to be x equals whatever h is, which, remember, this is a minus sign. So it's going to be the opposite of what you see here is what h is. All right, let's look at one example using all three of these forms. Here we have an equation, 3x squared plus 36x plus 33 equals 0. I want to find the y-intercept, the roots, the vertex, and the axis of symmetry for this problem, okay? So the easiest thing I can see already, this is in standard form, right? Let's see, what is our standard form? Our standard form, oh, it's already in there. I thought it was going to give me what the equation was. Our standard form is ax squared plus bx plus c equals 0, okay? So our standard form tells us what our y-intercept is. Our factored form is going to tell us what our roots or our answers are. So this is standard. Okay, the roots are from your factored. And then the vertex and the axis of symmetry we're going to get from the vertex form. Okay, so we can easily see where we're going to find all of these. It tells us right here, standard form. Oh, there's the equation. I knew I had it written in here somewhere. And so our y-intercept is 0, c. So in this case, what is our y-intercept? Our y-intercept is 0, what's c? It's 33. So our y-intercept is 0, 33. Okay, so in factored form, we can easily find the roots or the zeros or the solutions. So in this case, we're going to have x equals, there's no coefficient for these x's, so x equals -1 and x equals -11. And then vertex form here, we have, we can easily find the vertex as well as the axis of symmetry. And as you can see here, going back to this factored form, what they did is they took out the GCF of 3, right? And then they factored it. 11 times 1 is 11, and you add them together, you get 12. So then this one, you did negative b, negative 36 divided by 2a. 2 times 3 is 6. 36, negative 36 divided by 3 is going to be -6, which is why we have a positive here, because we always use the opposite. And then you plug that in for this equation and you solve, and you got -75. So that's how they got k. Vertex is HK. So what is our vertex? Our vertex is going to be -6, because H is -6. H is -6. It's the opposite of what we see. And K is -75. So -6, -75. And then what is our axis of symmetry? X equals -6. There we go. Y-intercept, roots, vertex, and axis of symmetry. We got them all correct. Great job. I know you're going to go do a great job on your assignments. You have 2 assignments after we just covered that page 3 in unit 3B. So go ahead and do both assignments now, and I'll see you on the next lesson.